Welcome to a Slice of Science. First of all, my heartful thanks to each and every viewer because with your encouragement only, we completed our first lesson successfully. Keep watching videos like this for better understanding with simple language. In this video, we are going to discuss about acids, bases and salts. With this video, you will be clear about acids and bases. The word acid comes from the Latin word acidus, which means sour taste. For example, if you consider lemon, tamarind, strawberry, tomato, these all comes under acidic substances. The taste is also sour. So, these are called as organic acids. Organic acids is also nothing but natural acids. These natural acids are obtained from the natural resources. Okay, examples are tomato, strawberry, etc. These all contains sour taste. These all have sour taste. Okay. Next, inorganic acids. In acids, we have inorganic acids also. For example, hydrochloric acid, sulfuric acid, nitric acid, etc. These all are called as inorganic acid. Inorganic acids means they are prepared with minerals. They are man-made acids. Okay. Next, coming to bases. Bases are opposite to acids. They are bitter in taste. Bases are bitter in taste and soapy to touch. Soapy to touch. For example, if you consider baking soda, which is used in cooking, it is also bitter in taste. And lime, which is used in the pawn shop for making pans, it is also contains little bit bitter taste. Okay, so they all comes under the bases. In bases also we have inorganic bases. Inorganic bases. For example, sodium hydroxide, magnesium hydroxide and calcium hydroxide, etc. These all comes under inorganic bases. Okay, so generally organic acids or organic bases, it is very easy to identify with their tastes, but it is difficult to identify the inorganic tastes because we can't taste them. So we'll test these inorganic acids and bases with the help of indicators. Indicators means the substance which is helpful to identify the substance whether it is acidic or basic. So in indicators, already you know, litmus paper. We have a lot of indicators. Litmus paper is also one of the indicator. Litmus paper is of two types. It contains two colors. There are one is red color, red litmus paper, and another one is the blue litmus paper. Okay. So the substances which turns blue litmus paper to red. The substances which turns blue litmus paper to red is called as acidic substances, and the substances which turns red litmus to blue. The substances which turns red litmus to blue are called as bases. For your better understanding, I will demonstrate it practically. Children, look here. What are these? These are acidic substances. Lemon and tomato are the acidic substances. And look here, what are these? These are the bases. So, surf and baking soda. I consider these three for proving practically the bases, nature of the bases. Already in acids we discussed that blue litmus paper turns to red. Acids turns the blue litmus to red. So now here I am taking a blue litmus paper and children, look here. I placed this blue litmus paper on tomato. Now you will observe what is the color of the litmus paper. Is it turns to red or not? Yes. Now look, it appears very clearly right now. Okay, now take one more litmus paper and put it on the lemon. Look here children, the blue litmus paper turning to red color. Okay, so by this we are clear about the acids turns blue litmus to red. Okay, next come to here. These are the bases. For testing bases we will use red litmus paper. Bases turns red litmus to blue. So now I am taking some water and I am for making it to wet. Here I am taking red litmus paper. I am placing the red litmus paper on soap. So children, okay, you will observe here almost it turns into blue color. Okay, next here already I mixed the washing soda and baking soda to water. Now take the red litmus paper and put the red litmus paper into surf. How it appears, ma? Blue in color or not? Yes. So the bases turns blue litmus paper into red. Similarly, now look the baking soda also. Look here how fastly the surf and the baking soda changing the color of the red litmus. Okay, so like this the bases turns red litmus to blue. We can also define acids as a solution which contains excess H plus ions is called as acidic solution, and a solution which contains excess OH minus ions is called as basic solution. Acids contains excess H plus ions and bases contains excess OH minus ions. So I'll explain this very clearly to you. For example, if you consider HCl. In HCl aqueous solution, HCl decomposes into H plus Cl minus ions. Okay. And H2SO4. If you consider H2SO4, this H2SO4 in aqueous solution, it decomposes into H plus SO4 minus. Similarly, HNO3. Here in aqueous solution, this HNO3 decomposes into H plus NO3 minus 1 ions. Okay. What is meant by aqueous solution? Aqueous solution is a solution in this water acts as a solvent. Means if you mix anything into the water, for example, if you take a small quantity of water, acid, if you mix the small quantity into a large quantity of water, then it is called as aqueous solution. Similarly, if you mix a small quantity of base into a large quantity of water, then it is also called as an aqueous solution. Similarly, salt also. Okay, if you mix any small quantity into a large quantity of water, then we call it as an aqueous solution. Okay, in aqueous solutions means when we add this small quantity of HCl solution into the water, then we call it as a HCl aqueous solution. In aqueous solution, the HCl ions decomposes into H plus and Cl minus ions. Similarly, H2SO4 decomposes into H plus and SO4 minus 2 ions. Similarly, HNO3 is also decomposes into H plus and NO3 minus 1 ions. Okay. By this, what we are understanding, acids decomposes into aqueous solution, they form H plus ions. Okay. Next, coming to bases. For example, if you consider NaOH, this in NaOH aqueous solution, it decomposes into Na plus OH minus ions and CaOH twice. It also in aqueous solution, it decomposes into Ca2 plus OH minus. Similarly, MgOH twice. This also decomposes into Mg2 plus OH minus. By this, what we are understanding, when bases in aqueous solution, bases gives OH minus ions. Okay. Now take a beaker. Take a beaker and fill the beaker with water. Next, for example, if you assume generally water contains H2O molecules. If this H2O molecule decomposes, which ions it produces? It produces H plus OH minus ions. Generally, it releases. Okay. So, for example, if you assume the number of H2O ions is X. Okay. So, when the water decomposes, the ions also decomposes into equal number. Means here we have X number of water molecules. So, we will get X number of H plus ions and X number of OH minus ions. Means we will get same number of H plus ions and OH minus ions. In case in water, if you add acid, the number of H plus ions increases in the water. So, this solution acts as acidic solution. Similarly, if you add bases into the water, if you add any base into this water, it increases the concentration of OH minus ions. So, this solution acts as base. So, children, by this explanation, I think you are very clear about the definition of acids and bases. So, look here once again. Excess H plus ions. Yes or no, ma? Here, when the solution contains excess H plus ions, then only we call it as acid. So if a substance contains excess OH minus ions, we call that substance as bases. Okay, and in this we have again two types. In acids and bases we have again two types. They are strong acids and strong bases, weak acids, weak bases. The acids which releases more H plus ions in aqueous solution, we call that acids are strong acids. Example, HCl, H2SO4, etc. So these all comes under strong acid. They releases more H plus ions into aqueous solution. Similarly, the acids which releases less number of H plus ions into aqueous solution are called as weak acids. For example, CH3COOH. It is called as a weak acid. When it decomposes, when it reacts with water, it releases only H3COO minus plus H plus. It releases a few number of hydrogen ions only into the water. Okay. Similarly, bases also. If the bases which releases more number of OH minus ions in aqueous solution is called as strong bases. For example, NaOH. NaOH is the example for the strong base. Similarly, the bases which releases a very less number of OH minus ions into aqueous solution, they are called as weak bases. Example is ammonium hydroxide. Ammonium hydroxide is the best example for the weak bases. Okay children, till now we discussed some of the properties of acids and bases. Let us recall them once again. Acids are sour in taste. Bases are bitter in taste and soapy to touch. Acids turns blue litmus into red. Bases turns red litmus into blue. So the examples for acids are lemon, tamarind, strawberry, hydrochloric acid, sulfuric acid, etc. And similarly, the examples for bases are sodium hydroxide, baking soda, lime and magnesium hydroxide. These all are the examples for bases. And the substance, the solution which contains excess H plus ions is called as acid, and a solution which contains excess OH minus ions is called as bases. So, in aqueous solution, the acids which releases more H plus ions are called as strong acids, and which acids releases less number of H plus ions are called as weak acids. In bases, the bases which releases more OH minus ions are called as strong bases, and the bases which releases less number of OH minus ions are called as weak bases. Till now we discussed these properties about acids and bases. Children, I think you are very clear about these properties. So our next I am going to explain about what are the uses of acids and bases in our daily life. If you consider acids, vinegar is used in cooking, preservating food and in cleaning. Next, carbonic acid. The formula for carbonic acid is H2CO3. It is used in soft drinks as a preservative. Next, sulfuric acid. Sulfuric acid is used in car batteries. Similarly, nitric acid. Formula for the nitric acid is HNO3. It is used in explosives and in the making of fertilizers. These are some of the uses of acids. Next, what are the uses of the bases in our daily life, ma'am? So, sodium hydroxide. Sodium hydroxide means NaOH. This base is commonly used as ovens and drain cleaner. And next, aluminium hydroxide. The formula for aluminium hydroxide is AlOH thrice. It is an active ingredient in deodorants and antacids. Similarly, magnesium hydroxide, MgOH twice. This base is also used in antacids. Next, sodium carbonate. Sodium carbonate is used as a dish detergent. And ammonium hydroxide, NH4OH. NH4OH is used as a glass cleaner. So, and last, sodium bicarbonate. This base is the active ingredient in baking powder. These are some of the properties of the acids and bases. Children, here I have given some common acids and bases with their names and formulas. Learn them perfectly. A compound of a metal with the hydroxide ion means OH minus ion is called hydroxide, which means in first one, look the first compound NaOH, sodium hydroxide. So here sodium is the metal. Similarly in second one also potassium is the metal, barium also metal, magnesium, aluminium, these also metals. So here the metals forming the compound with OH minus ion means these compounds are hydroxides. All hydroxides are basic in nature. In my next video, I'll come up with some more properties of acids and bases. Keep watching and don't forget to subscribe my channel. Thank you.